Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So now as you all know, we have started the chapter alcohols, phenols and ethers. So today we are going to do second part of this chapter, and today we are going to discuss the preparation of alcohols and phenols, and we'll be talking about its physical properties. Okay, so yes, I want all of you to join our WhatsApp channel also. The link of the WhatsApp channel will be there in the description section of this video, so please go there and join our WhatsApp channel so that you can get all the PDF notes, question paper solutions, everything in our WhatsApp channel. Okay, so yes, now I hope everyone watching this series every day and doing the questions with me, practicing the whole syllabus with me. So yes, please sit with a notebook and a pen, as I say in my every class. Please sit with a notebook and a pen, and so that you can note down all the important reactions and questions that we are going to discuss today. Okay, so yes, now let's get started without further delay. So first of all, one second. Okay, so now coming to like how we are going to complete this chapter. So I have discussed this in the first part of this chapter also. So there will be 4 parts of this chapter. Okay, so why I am doing this, because when you revise also you should do revision accordingly. Okay, so first of all you should revise the part 1 what we have completed. In part 1 we completed classification, then we completed nomenclature, and then we have done with structure, right? So these 3 first, when you revise, this much should be done. Next, in today's class, we are going to discuss preparation of alcohols, preparation of phenols and the physical properties. Next, in part 3, we will be discussing the most important part, that is chemical reactions of alcohols and chemical reactions of phenols. Next, coming to part 4. Okay, so in part 4, we are going to first discuss some commercial alcohols, and then we will be discussing everything about ethers. So we will be talking about the preparation of ethers, the reactions of ethers, and a lot of practice questions from ethers also we will be doing. Okay, so this is how you should be framing the chapter. Whenever you are sitting for revision of alcohols, phenols and ethers, you should think, okay, there are 4 parts. First part you have to revise this, second part this, then comes this. So in this way revision should be done. Okay, the structured, it should be very much structured way. Okay, so now coming to the year wise weightage. So every year you can expect 3 to 4 questions. So definitely a very high weightage chapter, I can say. From organic chemistry, alcohols and aldehydes, both the chapters are high weightage chapters. So yes, a must do topic. Okay, so now coming to today's topic, that we already know what all things we are going to discuss: preparation of alcohols, preparation of phenols, and then physical properties. Okay, fine. So now let us come to the first topic, that is preparation of alcohols. So in preparation of alcohols, we have 3 major sources from which we can prepare. Okay, the first one is from alkenes. Okay, next from carbonyl compounds, and then from using Grignard reagent. So these are the 3 things from which we can prepare alcohols. First is alkenes, then is carbonyl compounds, and then from Grignard reagent. Now in alkenes what happens? We have 2 methods, that is acid catalyzed hydration, and then we have the next one, that is hydroboration oxidation. Okay, acid catalyzed hydration and hydroboration oxidation, these 2 methods are there under from alkenes. Okay, next coming to from carbonyl compounds. So that is, one is reduction of aldehydes and ketones, and the next one is reduction of carboxylic acids and esters. Okay, and the last one is from Grignard reagent. Once again let us revise. From alkenes you have 2 methods, acid catalyzed hydration and hydroboration oxidation. From carbonyl compounds you have again 2 methods, reduction of aldehydes and ketones and reductions of esters and carboxylic acid, and the third one is from Grignard reagent. Okay, so next coming to the methods of preparation, here we will understand these reactions. So now you can see I have done a flow chart. So this is how you need to prepare in your notebook, so that you can revise all the methods of preparation within 1 page. You can write and remember it. Okay, so coming to the first one, see, from alkenes. Okay, the first method is from alkenes, number 1. So from alkenes I told you there is 2, acid catalyzed hydration. So this one, you see H plus H2O, hydration stands for addition of water, acid catalyzed, so there should be 1 H plus. So this method is your acid catalyzed hydration. Okay, what is the reagent you have to remember? H plus and H2O. Okay, now what does happen here? How does the reaction happens here? H and OH is added. I'll example also will do, but you have to remember here this follows Markovnikov's rule. Markovnikov's rule is followed here. Okay, now I'll give you one example, do not worry, we'll do with example. Now suppose I have propene. Okay, let us take one example of propene. CH3 CH double bond CH2. Okay, now if you add H plus and H2O, what will happen? H and OH will be added following Markovnikov's rule. According to the Markovnikov's rule, the negative part will go to the carbon having less number of hydrogen. So what is here? H and OH. OH is the negative part, H is the positive part. So what will happen here? If I add this one, okay, the first, that is H plus and H2O. So the negative part, that is the OH, will go to the carbon having less number of hydrogen. So if you see here, this is the carbon with less number of hydrogen. So OH will be attached here, H will be attached here. So what will be the product I will be getting? CH3 CH. Here I will add OH and H. So you can see we can get a alcohol from alkenes by adding H plus and water. That is acid catalyzed hydration. Okay. Now the same thing we can add, we can do BH3 whole 2 H2O2 OH minus. BH3 whole 2 H2O2 OH minus. This method is called as your hydroboration oxidation. HBO I am writing. Hydroboration oxidation reaction. Here what is the difference? Here it happens following anti-Markovnikov's rule. Anti-Markovnikov's rule. Okay. So now in this same compound, okay, propene, if you take and you add the reagent here, this one, that is BH3 whole 2, BH3 whole 2 H2O2 OH minus. If I add this one to propene, then the product I will be getting is CH3 CH CH2, and here I will have H and here I will have OH. So now you can see the difference here. This is your following anti-Markovnikov's rule, this is following Markovnikov's rule. Okay. So remember, let us revise. From alkenes we can add H plus and OH minus. If you use normal H plus H2O, then that will give you Markovnikov product. If you use BH3, that is hydroboration oxidation method, and you do, then we will get anti-Markovnikov's product. Clear? First method from alkenes, 2 reagents you have to remember. From alkenes we have 2 reagents. Okay. Now let us go to the second one, that is from aldehydes and ketones. Okay. So now aldehydes and ketones, they can be reduced. Okay. So reduction of aldehydes and ketones will give you alcohols. So one simple example, if you take for example CH3 COH is there. Okay. You treat it with any of these reagents like H2 palladium or NaBH4, we will get, suppose these any reagent you take, you will getting CH3, this part is there CH, and this one will get converted to OH. Okay. So now we will get a primary alcohol here. Clear? Similarly NaBH4, if you treat, same reagent, same product you will get, CH3 CH2OH. Okay. CH3 CH2OH. Getting? So reduction of aldehydes and ketones can be done with 2 reagents, H2 palladium or NaBH4. Okay. Next, coming to your reduction of acids and esters. Okay. So now you see here, for acids please remember LiAlH4 is very important. Okay. To reduce acids we need LiAlH4, that is lithium aluminium hydride. Okay. So you cannot reduce acids with NaBH4. Okay, that is important. Note down here, NaBH4 cannot reduce acids. Okay, so acids means I mean carboxylic acids. So for carboxylic acid we need lithium aluminium hydride. Okay, now lithium aluminium hydride is one of the way how we can reduce this acids into alcohols. And if esters are there, esters also you can use lithium aluminum hydride, or you can use hydrogen with palladium. Clear? Okay. So now I will revise once again. Okay, I want everyone to listen to me, the revision. First, alkenes, two methods. Acid catalyzed hydration follows Markovnikov's rule. Hydroboration oxidation follows anti-Markovnikov's rule. Clear? Next, aldehydes and ketones. You can reduce it with hydrogen palladium or NaBH4. Next, coming to acids and esters. For acids and esters, you can use LiAlH4 or hydrogen palladium, but remember, hydrogen palladium is only for esters. Next, coming to Grignard reagent. Okay, so Grignard reagent, you can treat any of these carbonyl compound, like especially aldehydes or ketones. Okay, if you react with aldehydes or ketones with Grignard reagent, then we will get alcohols. Okay, now what is the mechanism of reaction of aldehydes and ketones with Grignard reagent, we'll understand now. Okay, so now let us understand how do Grignard reagent will react with aldehydes or ketones. What is the mechanism to form alcohols? Okay, so it is very easy, and you just need to understand some basic principles that we should know. Okay, so let me take you one aldehyde. Okay, we have R C double bond OH. Okay, and you have a Grignard reagent R dash MgX. Okay, this is Grignard reagent. So first of all, assign plus and minus here. Okay, so remember, Mg is plus because it is a metal, R is negative. Okay, here if you see, oxygen will be negative, carbon will be positive, because oxygen is more electronegative than carbon, right? Now what will happen, this R minus will attack at the plus, okay, and this minus will take this plus. So what I will get the product here? So first let me write it like this, RCOH, okay, and then we have this one as R dash, okay, and here MgX. Okay, this part, positive part has come and attached on this oxygen, and this carbon has taken this R. Now what will happen, if you give some water, okay, this part will get converted to OH. Okay, so I'll get here R COH H and R dash. Okay, so now you have to remember that if we have formaldehyde, okay, if you take formaldehyde, then we will get primary alcohol. Okay, if you have taken this one as a formaldehyde, formaldehyde means what's the structure? HCOH. Okay, this will give you primary alcohol. Okay, now if you take any other aldehyde plus Grignard reagent, so here I am telling with Grignard reagent. So if you take any other aldehyde with Grignard reagent like this one, we will get secondary alcohol. Okay, and then if you take any ketone group, okay, and treat it with Grignard reagent, then we will get tertiary alcohols. Clear? So I hope the action of Grignard reagent is very clear. Just very simple, in the aldehydes or ketones will have CO groups, right? So you have to attach the R part to the carbon, MgX part to the oxygen. That's all. And then where OMgX is formed, just convert it to OH. Even if this H2O reagent is not given, you can still convert it to OH. Okay. So that is how are the methods of preparation of alcohols. Let us revise once again. First is from alkenes. Okay. In alkenes we have two acid catalyzed and hydroboration oxidation. Then we have from aldehydes and ketones, right? From aldehydes and ketones you have reagent H2 palladium and NaBH4. Okay. Then you have carboxylic acid and esters. Here also like you have LiLH4 and H2 palladium, then you have Grignard reagent. Okay. So now let us do some more example here. Okay, just a minute. Okay, so just let us practice one question like this. Suppose you have been given CH3 CO CH3 and you have to treat it with for example NaBH4, right? So this is a ketone can be treated with NaBH4 or hydrogen palladium. So what you have to do, the product here will be CH3, CH3, this one will become OH, and then you just add H to balance the valency of carbon. There should be 4 bonds, so just this O will get converted to OH, and after that if one more valency is left, just address it with hydrogen. Okay, like for example, you can take another reagent. Let us take like CH3COH plus H2 palladium. So this is aldehyde. So what will happen? First CH3, C, then H we have. First we will convert this to OH, right? Then you see carbon has 3 bonds now. It should have 4. So add 1 with hydrogen. Okay, so that is how we can reduce aldehydes and ketones to carboxylic acid, alcohols. Now if we see for carboxylic acids, for example CH3COOH. So for carboxylic acid we need the reagent LiAlH4, right? So here what will happen? The same thing you have to do. May write this one CH3, here this will become OH, okay, and then this OH will not be there, okay, just you have to balance the rest thing with hydrogen. Okay, clear? Reduction of carboxylic acid, aldehydes, ketones will give you alcohols. Okay, so I hope the preparation of alcohols is clear. From alkenes we have 2 methods, then we have aldehydes and ketones, you have 2 reagents, carboxylic acids and esters you have. Okay, with esters also we'll see one example now. First let me erase this part. For esters, if you see, we have suppose R dash, okay, and with esters you can use H2 palladium, or you can also use LiAlH4. So what will happen? This part, okay, this part will get your RCOH, okay, this part will not be there, this one you have to remove it, and then just to balance you have to add 2 hydrogens. Clear? Let us take one more example. CH3, CH2, COOCH3. Now if you treat it with hydrogen palladium, what will be the product here? See, this part will get converted to OH. CH3, CH2, OH. Okay, and then we have these 2 groups will be converted to 2 hydrogens. This one will be removed. Okay, clear? So this is how esters can react to give you alcohols. Okay, fine. Next, coming to preparation of phenols. So for preparation of phenols we have 4 major sources. Okay, first one is from haloarenes, next you have from benzene sulfonic acids, next you have from diazonium salts, and then last you have from cumene. Okay, so remember haloarenes, benzene sulfonic acid, diazonium salts, and from cumenes. Okay, we'll see these reactions now. So first one, chlorobenzene. Okay, so that is from haloarenes. So the first method is this one, that is from haloarenes. Okay, so you take any chlorobenzene or anything, okay, any haloarene you take and treat it with NaOH at very high temperature and high pressure. So what will these do? This will be a nucleophilic attack. Okay, this OH minus attacks on this one and chlorines comes out. Okay, so we get a phenoxide ion, you can say O minus Na plus, and then just treat it with HCl, and this H plus will come here and we can get phenol here. Okay, haloarenes, just take any chlorobenzene NaOH, you will get O minus Na plus, and then treat it with HCl. First one. Second one is from your benzene sulfonic acid. So from benzene sulfonic acid. So this is pure benzene, just treat it oleum, concentrated H2SO4. What is oleum here? Concentrated H2SO4. So if you treat it with concentrated H2SO4, we'll get SO3H. This is benzene sulfonic acid. Okay, this is benzene sulfonic acid. From here you add NaOH and H plus, it will get converted to phenol. Clear? Second one. Now third one is from aniline or from benzene diazonium chloride. Benzene diazonium chloride. So here first you have to take any aniline, okay, benzene with NH2 group is called as aniline, then treat it to convert it to benzene diazonium chloride by using NaNa2 or NaNO2 and HCl, or you can use nitrous acid, okay. After getting this one, just treat it with water, OH will come, N2 plus and Cl minus will go, and we'll get phenol here, okay. Third one. Next, fourth one, this is very important method, okay, from cumene, okay. This is your, that is isopropyl benzene. You treat it with oxygen. So here what happens, oxidation takes place, then you treat it with H plus and water, and you will get phenol, okay. Let us revise all the four methods. First one is from haloarenes. Take any haloarene, treat it with NaOH at a very high temperature and pressure. This will give you O minus Na plus, and then treat it with HCl, you will get phenol. First method done, okay. Second method is from benzene, this is number 2, okay, and then you have, this is number 3, and then this is number 4, okay. So next one is from benzene sulfonic acid. So you have to take benzene, treat it with concentrated sulfuric acid to get benzene sulfonic acid. After getting benzene sulfonic acid, just you have to treat it with NaOH H plus, okay. Next, coming from aniline. So first from aniline we need to get benzene diazonium chloride, okay. Benzene diazonium chloride we can get using NaNO2 HCl. Once this is formed, just treat it with water and warm water, you will get OH, okay. And the last one is very, very important. So this is fourth one is very important method from cumene. First, that is isopropyl benzene, take O2. So oxidation will take place, and then H plus and water will give you phenol, okay. I hope these all four methods are clear now, okay. Now let us go to the physical properties, okay. So under physical properties we have two things, boiling point and solubility, okay. So you know boiling point is directly proportional to what? Boiling point is directly proportional to intermolecular forces, and intermolecular forces is directly proportional to mass, okay. So the boiling point of alcohols, phenols increase with the increase in the number of carbon atoms. If the carbon atoms will be more, okay, mass will be more. If mass will be more, then van der Waals forces will be more, right. That is why when carbon atoms increases, mass increases. Intermolecular forces here is nothing but van der Waals forces, right. So van der Waals forces will increase, and as a result of which boiling point will increase, right. So in alcohols, the boiling points decrease with the increase of branching in carbon chain, okay. So if there is, so again boiling point decreases with the increase in branching. Again, what is the reason? If branching is there, then van der Waals forces will decrease, then boiling point will again decrease, okay. Very simple here. So in alcohols, the boiling points decrease with the increase of branching in the carbon chain, because of this branching the van der Waals forces decreases, okay. So because of decrease in van der Waals forces with a decrease in surface area, okay. So next, coming to solubility. So solubility of alcohols and phenols in water is due to their ability to form hydrogen bonds with water molecules, so as shown. So you can see here, we can just, one second, yeah. So if you see, hydrogen bonding can take place easily with water. So suppose I have alcohol, okay, and then we have water, right. So there can be intermolecular hydrogen bonding between the water and the alcohols and phenols, and that is why the solubility is very high, okay. The solubility decreases with the increase in the size of the alkyl group or the hydrophobic group. So the more is this R group, okay. If this R group is big, then solubility will be less, clear, okay. So yes, now coming to some practice questions, okay. These are all previous year questions that we can practice to understand how much we have prepared today, okay. Compound P and R in the following reactions are. First, you see CH3CHO is given with CH3MgBr. You can see Grignard reagent, then you have aldehyde, Grignard reagent and aldehyde which H3O plus, which will give you an alcohol. So first let us do the first part. So first we have CH3CHO, and you have been given with Grignard reagent, CH3MgBr. So in Grignard reagent, I told you the trick. I hope all of you remember. Just you have to identify plus minus plus minus. Minus and plus will attack, plus and minus will form bond, right? So here you see this is plus, this is minus, this is minus, this is plus. So this one will attack here, right? So what I'll get? CH3, C, this O, MgBr will form first, right? Then here we have H and then we have CH3 here. But then you see there is again H3O plus is also there here. So this H3O plus will convert this OMgBr to OH, right? So what will happen? This one finally I'll get is OH. This is P. After that you have taken concentrated H2SO4. So concentrated H2SO4 is nothing but dehydration, okay? It removes OH and H group. So what will happen? There will be dehydration and we will get an alkyl group, CH3, CH double bond CH2, okay? So this is your Q. Next, B2H6 H2O2 OH minus. So we have written BH3 whole 2. If you remember in hydroboration oxidation, this is equivalent to writing B2H6. Okay, so that means if you remember, it adds H and OH but following anti-Markovnikov's rule, right? So anti-Markovnikov's rule means what? Negative part will go to the carbon having more number of hydrogen, right? So OH will go to this carbon, H will come to this carbon. So what product I'll get? CH3, CH2, CH2, OH, right? Now the question is asking P, and so let us write P properly here. So once again, yeah, so this is P and this is your R. So what is the relation between P and R? So if you can see, P, the OH group is at the second position, in R the OH is in the first position. So the functional group is present at two different positions, then we call it as positional isomers, right? So the correct answer for this question will be option number A, positional isomers. Okay, very good. Now let us move to the next. Which is most viscous? Now for viscosity, what is the, how does viscosity depends? So see, viscosity depends on intermolecular forces, okay? If more intermolecular forces will be there, then it will be more viscous. Now intermolecular forces will depend on number of OH groups, okay? More number of OH groups, more there is intermolecular hydrogen bonding, more viscosity will be there. So if you see in ethylene glycol there are 2 OH group, in glycerol there are 3 OH group, methanol 1, ethanol 1. So definitely glycerol is having more number of OH groups, so it will be more viscous. Okay, option number B. Okay, next, the steps involved in the conversion of propane 2OL to propane 1OL are in the order. Propane 2OL. So we'll write like this. This is propane 2OL and I want to get propane 1OL. Okay, first one is heating with PCl5. Okay, if you heat with PCl5, so we have heating with PCl5 first option, here also first option, here dehydration, okay, then you have dehydration. Okay, let us first assume all the options and check. Heating with PCl5, so if you heat with PCl5, I'll get first this one, right? Then heating with alcoholic KOH, so alcoholic KOH will do your dehalogenation and will get double bond this one, okay? Then acid catalyzed water. If you do acid catalyzed addition of water, it follows Markovnikov's rule. So if you see acid catalyzed, so if I write the structure, this is CH2, CH, CH3. So acid catalyzed water will give me OH here, following Markovnikov's rule, right? So this is not the product that I want, right? So option A is incorrect. Now here what happened, next one we have heating with PCl5, heating with alcoholic KOH, hydroboration oxidation. Okay, so now we can try this one here. See, if I say so, the second option, up to this it is correct. Here hydroboration oxidation if I do, then what I'll do, OH and H will be added following anti-Markovnikov's rule, right? So OH will be added to the carbon having more number of hydrogen, so I'll get CH2 OH, CH2 CH3. This is one propanol. That is what is asked in the question. So yes, definitely option number B is the correct answer. Now let us see what happens if we do option number C here. Okay, let us try with option number C also. Okay, so if you see option number C, okay, so now see, if we try option number C here. So first there is dehydration, so I'll get double bond this one. First dehydration. Addition of HBr in peroxide if I add. So that will be this one. Then heating with alcoholic KOH will again give you double bond. Right? It is not giving you alcohol. Similarly here dehydration, addition of HBr. So here if you see option number D. First we get dehydration, then addition of HBr. Addition of HBr is done. So this will give you Br here. Here addition of HBr without peroxide it is given, right? That means Markovnik of addition. So negative part will go to the carbon having less number of hydrogen. Then aqueous OH will give you this one, right? So yes, this also cannot be the answer. This also cannot be the answer. Answer has to be option number B. So let me write down the correct option again here, so that you can get the correct answer in your notes also. Okay. So first of all, see, first when you treat it with heating with PCl5. So if you treat it with PCl5, so we will get, okay, I am not writing H every time, but please make sure that you balance it with H. Okay, then you are treating with alcoholic KOH. So this will do dehalogenation. So we will get CH2, then CH, CH3, right? Alcoholic KOH. Then the last one is acid catalyzed addition of, hydroboration oxidation. I am just writing HBO. So this will add water following anti-Markovnikov's rule, right? So we will get this one as the product. This is your propane 1OL, right? So correct answer is option number B. Okay. Next question. Okay. Next we have, again you can see Grignard reagent is there. So first of all, the compound is like this. You have CH3 MgBr. Okay. So here you can see this is plus, this is minus, this is minus, this is plus. So minus will attack here, right? So what I will get here? We'll have OMgBr, okay, and then this side CH3 will come. Now I told you, even if water is there, after that water is there, so this will remove this one, so we will get OH, right? So what is the IUPAC name of this compound? So when functional group is there, you have to give least priority to the functional group. So I have to number from this side 1, 2, 3 and 4. So on the third carbon we have methyl group, so 3 methyl, then parent chain is having 4 carbons, so butane, and 2 on the second position we have OH, so the suffix will be OL. So 3 methyl butane 2 OL, that is option number A. Okay, fine. Next question. In the reaction their product Z is, okay, first is given ethanol. So just simply write ethanol, CH3 CH3. Sorry, CH3 CH2 OH. One second. Yes, so we have, this is ethanol. With PCl5, we have studied in the preparation of haloalkanes, right? One of the method was using PCl5, you can convert ROH to RX, right? So PCl5 will give you chloroalkanes, okay, chloroalkanes. So what will be the product here? CH3 CH2 Cl. Then you do alcoholic KOH, dehalogenation. So one hydrogen and one chlorine will be removed and we will get alkene. Okay, so let me write, this one is X, this one is Y. Then after this, at concentrated H2SO4 room temperature, so addition of water and you have H plus water. So just you can see H2O, so we write H plus H2O, right? Here you can see H2O is there, but H plus is not given you directly, but H2SO4 is given you, right? And H2SO4 is nothing but an acid, right? So acidic medium, you are adding water. So what does it do? It adds water following Markovnikov's rule. But here it is a symmetrical alkene, means there is no role of Markovnikov or anti-Markovnikov. Simply you have to add one H and one OH. So we had like this, and now I will add one H and one OH. So what I'll get? CH3 CH2OH, CH3 CH2OH. So correct answer for this question will be option number D. Okay, fine. So yes, now this is a homework question for you. The solubility of phenols in water is lower. This can be attributed to, okay. So you can find any 4 of these options and you have to comment down the correct answer, okay. Fine. So that's all in today's class. I want everyone to revise all the methods of preparation of alcohols and phenols, okay, and then you have to see the next class, okay. So I hope you have enjoyed today's class, and please come in the next class by preparing the preparation of alcohols and phenols. Remember all the methods of preparation, draw the mind maps and keep it ready for revision, okay. And see you in the next class, and please do not forget to subscribe the channel and join the WhatsApp channel. Thank you and see you soon in the next class.